Okay, good evening. Can you hear me?
Yes.
Thank you. Okay, so I think it's a good idea if we go through one exam completely from the beginning to the end as a recap. If we can get extra time, then I can answer some of the questions that are left, or if you have any questions. Um, so let us start solving these problems one by one. So this is the exam in 2017, January, and I haven't used any one of these questions when I was doing my lectures. So they haven't been covered before at all. Okay, so let us see what the problem is. Show that this capital F of x defined in this way is an antiderivative of this function for each choice of the constant c. Okay, so if you want to solve this problem, part A, I think it would be easier to use derivative and the definition of antiderivative. This capital function is an antiderivative of this function if I can show its derivative is equal to f of x. Yes, so I would say that I calculate f prime of x and show that this f prime of x is equal to f of x for all c. If I can show this, it means that I am done with the first part. And that is actually simple, yes, because you know the derivative of ln function. So ln of u, so let me recap everything here. So we know that ln of u, if you want to take the derivative of that, it becomes u prime divided by u. So here I do the same. Let me also turn on this feature. Okay, so I take the derivative using this rule. So it becomes the derivative of u, which is this expression. Here this expression is playing the role of u. And then divided by the u itself. So it becomes x plus square root of x squared plus a squared. Yes? And please interrupt me if you don't understand something. And of course the derivative of a constant is 0. So yes, this becomes 0. But now the derivative of the numerator, the derivative of x is 1. And then hopefully you remember the derivative of a square root of u is u prime divided by 2 square root of u. Okay, so I use this and differentiate this one, so it becomes plus 2x, which is u prime, divided by 2 times square root of x squared plus y squared. Plus a squared, sorry, and the whole thing divided by this expression. Okay, so here this 2 and that 2 are simplified. And then what I do, I take the common denominator here, so it becomes the square root of x squared plus a squared, and then plus x divided by square root of x squared plus a squared, and the whole expression divided by x plus square root of x squared plus a squared. But you immediately realize what is happening here in this numerator and here. They are the same, so they can be cancelled out. So this one and that one are gone. So what is left for us is just 1 over the square root of x squared plus a squared. And that is exactly equal to f of x. If I go back here, so this is just little f of x. Yes? So we were able to show that the derivative of this function for all possible values of c is this one, so it means that the first part is done. And then we're supposed to calculate this integral, but of course it is a very big hint here how to calculate this, because if you see the form of this function is exactly like this, so immediately you realize that if I choose a equal to 4, this function is actually this function. So for part B, what I need to do, I want to calculate integral from 0 to 3, 1 over the square root of x squared. Instead of 16 I write 4 to power 2 dx. but we just learned that this function by this form is a primitive function of this one. So the integral of this should be ln of x plus square root of x squared plus 4 squared. Of course, I should write c, but because this is a definite integral, I don't need to put c because c will be cancelled out. So I will write it from 0 to 3. Okay, and then I put 3. So this becomes a 3 plus, and then if I put 3 here, 9 plus 16, 25, square root of 25 is 5, minus ln of, when I put 0, it becomes 4. So this becomes ln of 8 minus ln of 4, which I prefer to write it as ln of 8 over 4, and this can be simplified as ln of 2. So here the question mark is the value of this definite integral is ln of 2. So it's actually very simple. Yes? Okay, any questions? So let us go to the next problem. So we are supposed to calculate this integral. Okay, so I don't know why this is in Swedish, the other one was in English. Anyway, so we are supposed to calculate this integral. I don't know, you need to be familiar with these type of integrals. Hopefully you immediately realize this can be calculated using the integration by parts. Yes, so if I want to solve part 1, I would consider that arc sine of x be equal to u and dx be dv. Of course, immediately I differentiate both sides. So if you remember, the derivative of arc sine of x is just 1 over 1 minus x squared, and then you multiply it by dx. It becomes du. And from here, because dx is equal to dv, x is equal to v. Okay, so and then the integral that you have, integral from 0 to 1/2 arc sine x dx is actually integral from 0 to 1/2 u dv, which according to the formula can be written as uv from 0 to 1/2 minus integral v du from 0 to 1/2. But we both know what are u and v. We know both of them actually. So x times u times v. U is this expression, v is this expression. If I multiply them, it becomes x arc sine x. It is supposed to be calculated between 0 and 1/2 minus v is this expression, which is x. Du is the whole expression. So I multiply x by that. It becomes integral from 0 to 1/2 x over 1 minus x squared dx. Okay, so we have to calculate these things separately. So yeah, let me, I don't know, call this one I don't know, for example a, and let me call this one I. Okay, so to calculate a, I need to put 1 over 2 there, so it becomes 1 over 2 arc sine of 1 over 2 minus, when I put 0 it becomes 0, yes? But arc sine of 1 over 2 is pi over 6. So it becomes 1 over 2 times pi over 6, which is pi over 12. So this is the value that I get for a. But when I want to calculate the other one, I have to use a substitution method, yes? So if I want to calculate I, for calculating I, what I have to do, I have to take, for example, 1 minus x squared to be a new variable. So let me change the letter, for example, t, and then immediately I differentiate both sides. It becomes minus 2x dx is equal to dt. But if you go to the integral, you see that you need this combination. So from here, I divide everything by minus 2. So the combination that I need emerges. Yeah? So it becomes minus 1 over 2 dt. Okay, and then so the integral I that I am looking for becomes integral. Okay, this is a definite integral. I have changed the variables. I myself always prefer to change the limits. So what should I write? I would say that because you are telling me that x goes from 0 to 1/2, I can conclude what happens to t. How? I put 0 instead of x, t becomes 1. So the lower bound, the lower limit is 1. And then x is 1/2, so I put 1/2 here, it becomes 1 minus a quarter, so it becomes 3/4, yes, so t becomes 3/4, so this goes to 3/4, so the integral goes from 1 to 3/4. In the numerator here, I put minus a half dt, and in the denominator I have a square root of t, sorry. Okay, and then this is also, I put minus over 2 out, then it becomes integral from 1 to 3/4. T to the power of 1/2, I bring it up, it becomes t to the power of minus a half, and then this is a famous integral, so it becomes t to the power of 1 unit more, it becomes 1/2 divided by 1/2, and then it goes from 1 to 3/4. But this 1/2 here and this 1/2 are cancelled. So what is left is minus square root of t, because t to the power of 1/2 is a square root of t, and it goes from 1 to 3/4. And then here it becomes minus the square root of 3/2 plus 1. Yes? So in total, what would be the question mark? So the question mark is a minus I, yes? So what is a? A, I got pi over 12, and then I got I this one, but if I multiply it by a negative sign, it becomes positive 3/2 minus 1. So that would be the answer to the first part. Okay, any questions? Now we are supposed to calculate this, the limit. I don't know why they have written it in this way, we shouldn't write this here. So the limit of an when an is this expression. Okay, actually if you see, this is not an infinite series, but it's like a geometric series, yes? And then immediately we know how to calculate the formula. So in principle, this is, I don't know what they mean exactly here. So let me go to part B. So the sigma that we are looking here, the sequence is I goes from 2 to n, 2 to the divided by 3 to power I. So if I write some of the first terms, for example, if I replace I with the first index, which is 2, it becomes 2 to the power of 2 divided by 3 to power 2. The next one is 2, 3 to the power of 3. The next one is 2 divided by 3 to the power of 4, and it continues until I reach to the end, 2 divided by 3 to the power of n. Yes? So it means that this is the sum, but when you want to calculate the limit of n goes to infinity, I hope that you immediately realize every time this term, the previous term, is multiplied by a third, yes? So, and 1/3 absolute value is smaller than 1. So this is a geometric series whose first term is this, and its common ratio is 1/3. And if you know the formula, so the limit becomes the first term, which is 2/3 to the power of 2, 1 minus the common ratio, which is 1/3. So if I calculate this, it becomes 2/9, and then it becomes 2/3. And if you calculate this, it becomes a third. So the question mark for this one is 1/3. So what is important here to realize that even though this series is not an infinite series, but when you calculate this one and send to infinity, so you are facing this series. And this series is actually a geometric series, and then you can use the tricks for geometric series to calculate this limit. Or of course you can use geometric progression that you learned in high school to write a formula for this, it becomes something depending on n, and then you calculate the limit of that expression and send to n infinity. But I think this is easier to do it in this way. Any questions? Okay, so let us go to the next problem. The function f is given by f of x equals to -6 plus absolute value of x plus 3 plus absolute value of 4 minus 2x. Determine all real numbers x that solves the equation. I don't know, this is not equation, this is inequality. So you are supposed to solve this inequality. Okay, and then they have given hints that sketch the graph. Okay, I myself prefer to solve it without sketching the graph. Okay, but let me solve it my way, but then of course I can also sketch the graph as a different practice. So what we have to do here, we want to solve this inequality. So instead of f of x, I put -6 plus absolute value of x plus 3 and then plus 4 minus 2x. This is supposed to be smaller than 0. I move 6 to the other side. Then it means that I have to solve this inequality and find all possible values. So as I told you always, if you remember when I was teaching absolute value to you, so there are 2 points that are important. Absolute value is always more or less useless in practice. So this number is -3 here, okay, and this number here, if I put it equal to 0, I get 2. So 2 points are important for me. So one of them is -3, the other one is, for example, 2. So it means that I have 3 regions to consider. This region, and that region. Yes? So let me consider it 1, 2, and 3. Okay? So I will consider all the numbers less than -3. What happens in this case? Okay, if I choose x less than -3, then this is negative. If I choose x smaller than -3. So it means that I can remove the absolute value sign safely, but the price that I have to pay is to multiply by an extra negative sign. If I have x less than -3 and I put it here, definitely this expression becomes positive. When it is positive, I don't need absolute value at all, so I just simply remove that. Yes, less than 6. And then I solve this inequality. It's a high school problem now. So it becomes -x minus 2x, which is -3x. And then what I have is -3 plus 4 is 1. I move 1 to the other side, it becomes 5. And I divide both by -3, so you need to remember to have to swap the direction of this sign. It becomes -5/3. Okay, so this tells you that x should be less than -3, yes, and then when I solve that under this condition, I got x should be -5/3, but there is nothing in common, yes, because -5/3 is -1, for example, a little bit then, -1.6. So this tells you that if this is -1.6, this should be greater than that. But on the other hand, this tells you that x should be less than -3 if -3 is here. So is there something in common between them? So the answer is no. So so from the first part, if x is less than -3, I do not have any solutions coming out here. So the first one gives rise to the empty set. So I cannot get any solutions between them. Yes, of course you need to explain these in detail in the exam. Okay, let us consider the second region. Yes, so that was the first region. So the second region, I consider -3, which I didn't consider before, and then I go up to 2. So let us see what happens here. Here I am sure that x is greater than -3. So when x is greater than -3, this is definitely positive, so I don't need absolute value signs. But what happens for the next one? Still this is positive, yes, because x is still below 2, so it means that this is still positive. So what I can get, I can write 4 minus 2x less than 6, and if I solve that, it becomes minus x less than minus 1. I divide by minus 1, so it becomes x greater than 1. But now here I need to find the common part between these two. So what I do, I would say that if I want to draw a picture for myself, so here is minus 3, for example, here is 2, and here is, for example, 1. This condition tells you that you are here, yes, this condition, and then this condition is telling you that you are supposed to be greater than 1. So if you see, the intersection is here, okay? It excludes 1, it also excludes 2. So it is greater than 1, smaller than 2. So I get 1 less than x less than 2. So a partial answer is this. Here a partial answer is the empty set. And then I need to consider the third one. So if I want to consider the third one, I go x greater than or equal to 2. If x is greater than or equal to 2, this is positive, but then suddenly this becomes negative. So the first one, I just simply write x plus 3, and the second one I would write it minus 4 minus 2x less than 6. And if I solve that one, so it becomes 3x less than 7. Yes? So what happens here? It becomes x less than 7 over 3. Then I need to convince myself what is here. So assume that this is 2, this is 7 over 3. This tells you that x is greater than 2, so it's something like this. It goes to this direction. And then x should be less than 7 over 3, yes? So the intersection is exactly between 2 and 3. But 2 is inclusive, 7 over 3 is exclusive. So another partial answer is x greater than or equal to 2 less than 7 over 3. So I have 3 partial answers, but I am interested in the total answer. So I need to append them together. So I need to union them. So I don't need to be worried about that. That's a null set. But this tells you from 1 up to 2 is acceptable. But this tells you from 2, including 2, is also acceptable up to 7 over 3. So the final solution would be this, from 1 up to 7 over 3. So that is what you have to write for the answer to this problem. Okay? The final answer. So you see that you can solve it analytically. You do not need to draw that. Might be, if you draw that one, that is also probably one way to solve this. So for example, if you want to draw it, more or less what you have to do, so let me write the function here. F of x is equal, so let me write it in this form: absolute value of x plus 3 plus absolute value of 4 minus 2x and minus 6. Of course, you need to also consider this, that you have to do. This means that you need to more or less do the same things. So 1, you consider x is less than minus 3. Then instead of f of x, let me write y here. And then the first one is negative, the second one is positive, and then I have a minus 6. So if I simplify that, it becomes minus 3x, and then you have 1 minus 6, which is minus 5. So it means that you need to draw this line. Okay, so you need to draw this line when x is less than minus 3. Okay, so you draw the graph of this function, it becomes some lines, and then you see where this graph is above the x-axis or below. So let me see, no, below the x-axis, because you are interested in those parts that the function becomes negative. So you need to understand where the function, the graph of the function goes below the x-axis. Okay, so I don't know, this is actually not a very good way because you need to draw how many lines? 3 lines, yes? Yes, so for example, if you draw the graph here, you need 2 points. For example, I would say x minus 3, and let me choose minus 4. Yes, minus 3 is this one, minus 4. Okay, so minus 3, if I put minus 3 here, it becomes 9, y becomes 4, and if I put minus 4, it becomes 7. Okay, so for example, you draw a graph, x is minus 3, for example, minus 1, minus 2, minus 3, and 4, for example, here, and the other one is minus 4 and 7. So for example, something like this. Okay, so you connect these 2 points, but of course here minus 3 is excluded, so this continues forever from this direction, but you need to put the hollow circle. But of course the next line coming in will make this filled. Okay, so you just draw this graph and you see where the graph goes below the x-axis, and then you can solve the equation using that, because you are interested here to have f of x less than 0. I don't think it is a good idea if I want to continue this, because this is very simple. Any questions, by the way? If you have difficulties here, I can continue. But what I'm telling you is that you really don't need to sketch. This analytic way of solving the problem is actually okay, and you get the correct answer. No questions? Okay. So let us see what the question number 4 is. So the position y of t of a particle in a force field at time t satisfies this differential equation. If you know that this is the answer, what are the values of a and b? I don't know, might be there are different ways to see this problem. So if I ask you what is the characteristic equation of this differential equation, hopefully you remember from that lecture that the characteristic equation of this differential equation is R2 plus AR plus B equals to 0. So if you remember, for solving a differential equation, we were supposed to find its characteristic equation and put it equal to 0, depending if there are 2 real roots, 2 complex roots, or 1 double root. We have different scenarios. But when you look at the solution, if you remember what was going on there, so you realize that the roots of this equation are supposed to be minus 3 and 2. Okay, because the answers that we get here say they are R1 and R2. If they are real, do you remember we write something like this: C1 e to power R1x plus C2 e to power R2x, and that would be the solution. Of course here the variable is t, sorry. Okay, so now by looking at the given equation, I realize that one of the roots of this equation should be minus 3 and one of the roots of this equation should be 2. So r equals to minus 3 is a root. So what does it mean? It means that it satisfies this equation. Sorry, minus 1 is not, minus 3. So instead of r, I put minus 3. And then I get an equation. Minus 3a plus b is equal to minus 9. This is one equation. Yes? And then I see that r equals to 2 is a root. This implies that 2 satisfies this equation. Yes? And then I get this equation, 2a plus b equals to minus 4. And if I multiply it by a negative sign, it becomes minus 2a minus b is equal to 4. The reason that I did this because I want to solve this system. So I put them in a system of equations. Minus 3a plus b is equal to minus 9. And minus 2a minus b is equal to 4. And then I add them, yes? When I add them, this becomes minus 5a is equal to minus 5. So I got that a is equal to 1. And when a is equal to 1, I put it in one of these equations and b becomes what was that? Minus 3 and minus 6. So what are the values for a and b? We were able to find the values for a and b. That was actually very simple. Yeah, this exam doesn't seem having hard questions. So solve the differential equation when a is equal to minus 5 and b is 6 with the initial value conditions that you see here. Okay, so part B, if I want to solve this equation for minus 5 and 6, so okay, instead of characteristic equation, instead of a I put minus 5 and instead of b I put 6. So this becomes r squared minus 5r plus 6 equals to 0. Okay, and if you solve this using PQ formula or any way that you know, the answer becomes r equals to 2 or r equals to 3. Yes? Yes, these are the answers. And then the y becomes equal to a constant. Let me call it, yes, C1 times e to the power of 2t plus C2 e to the power of 3t. And then we want to satisfy these initial conditions. So y of 0 is supposed to be equal to 1. So instead of t I put 0, the answer is supposed to be 1. But if I put t equal to 0, the first term becomes C1, the second term becomes C2, so that is equal to 1. And I need to differentiate first. So it becomes 2c1 e to power 2t, and the other one becomes 3c2 e to power 3t. And then I differentiate, so you see that y prime of 0 is supposed to be 4. So I calculate y prime of 0, so it becomes 2c1 plus 3c2. And this is supposed to be equal to 4, yes, yes. So 2c1 plus 3c2 is supposed to be equal to 4. So here I have one relation, and here I have one relation. So actually I solve the system. C1 plus C2 is supposed to be 1. 2c1 plus 3c2 is supposed to be 4. For example, if I multiply the first one by minus 2 and add it here, C2 becomes 2, and then C1 becomes minus 1. And then what you have to write as the final answer is minus e to power 2t plus 2e to power 3t. So that would be the answer that you have to provide for this part of the problem. Yes, when I found them, I put them back here in this equation. Okay, any questions? Okay, so let us see other questions. Okay, so another question is also probably a very standard one here. So a function is given to you. Compute the Taylor polynomial of degree 1 of f of x around x equals to 1. So what should I do? Because I need degree 1 Taylor polynomial, so let me write the formula. So it becomes p of x, assuming that this is the Taylor polynomial. Because it is supposed to be around 1, I have to write f of 1 plus f prime of 1 divided by 1 factorial x minus 1. So this is actually extremely simple exam, I think. I don't know why. So p of x is equal to this. So that's the first degree Taylor polynomial for that function. So immediately, let me simplify it. It becomes f of 1. 1 factorial is just 1. And then I have this one. Okay, so what I need to do, I need to calculate f1 and f prime of 1. So f1 is actually arctangent of 1 to power 2, which becomes arctangent of 1. But arctangent of 1 is pi over 4. For the second part, first I need to differentiate the arctangent function. So hopefully you remember that the derivative of arctangent of u is u prime divided by 1 plus u squared. So that is the formula for the derivative of arctangent. So I apply this here. The derivative of u becomes 2x divided by the denominator squared, 1 plus u squared, which is x to the 4. And then I am supposed to calculate f prime of 1, so I replace x with 1. Yes? And the answer becomes equal to 1. And then everything is ready, so my Taylor polynomial is equal to f of 1 is pi over 4 plus f prime of 1 is 1, and I multiply it by x minus 1. So this is very, very simple. Okay, and then on the second part we are supposed to show that this should be point, yes, 1.1. We want to show that this absolute value is less than 1 over 50. And I think you have enough experience. This is the error that we make. So let me, by the way, let me calculate p of 1.1. So this is for part B. If I calculate p instead of f, let me calculate p at this point. So it means that instead of x, I have to put that expression. So this becomes equal to pi over 4 plus 1.1 minus 1. So this becomes pi over 4 plus 0.1, which is written in fraction form in the question. So this number that you see here is just calculating p at the given point. So this is the approximate value to f of 1.1. This is the real value, this is the approximate value, and this is the difference between these two. And because there is absolute value, so it doesn't matter, because you remember that the definition of E was f minus p. But here it's p minus f, but because it is in absolute value, it doesn't matter. So if someone asks you what is this, this is just the error that we are making here. So absolute value of pi over 4 plus 1 over 10 minus f of 1.1 is nothing except p of 1.1 minus f of 1.1, and that is the absolute value of error 1.1. So why I have written here, because this is the first order, so the error is also related to the first order. But then you need to remember the general formula, so En(x), so let me write it with a different color. So this you need to remember, Lagrange remainder, En of x is equal to f n plus 1 c divided by n plus 1 factorial multiplied by x minus a to the power of n plus 1. C lies between a and x. So this is something that you need to remind yourself from that lesson here. Okay, so now let us see what happens. Here x is 1.1, n is 1, a is given to be 1 in the problem. So here in this case, if I want to write E1 1.1, this becomes equal to, oh, by the way, I need to calculate, let me write it here. So this becomes f of the second derivative at c divided by 2 factorial, and then 1.1 minus 1 to the power of 2. So this implies that E is equal to f double prime of c 2 factorial is just 2. And what is this number? This becomes 1 over 10 to the power of 2. So this becomes 1 over 100. So finally, E1 1.1 is 1 over 200 f double prime of C. And now if I ask you where is C, you would say C lies between A, which is 1, and X, 1.1. Yes? So this is what we got. But now we want to show that the absolute value of this error is actually less than 1 over 50. So if I want to talk something about this, I need to calculate f double prime of C. So what I do, I have already calculated f prime, so I need one more derivative to calculate f double prime. So let me just do it here. So f double prime of x, the derivative of the numerator multiplied by the denominator, minus the derivative of the denominator multiplied by the numerator, divided by denominator squared. If we simplify that, so it becomes 2, and then I have 2x to the 4 minus 8x to the 4. So I factor a 2 out, so it becomes 1 minus 6. Let me write it 2 steps. So it becomes 2 minus 2 minus 8 is minus 6x to the 4, and then divided by 1 plus x to the 4 to the power of 2, and I factor a 2 out, it becomes this. Yes? Oops. Okay, to the power of 2. Okay, so what we have to do, okay, now let me take the absolute value of this expression. By the way, if I put C here, this becomes C, this becomes C. These two that you see here will simplify this one. So E1 at 1.1 is equal to 1 over 100, and then I will have 1 minus 3c to the 4, 1 plus c to the 4. Okay? And then when I take absolute value of this, I also have to take absolute value of the right hand side, but this is positive. This is positive, so the only absolute value that I have to put is there. So this becomes 1 over 100. Yes? Pardon?
Wasn't that squared?
Yes, thank you very much. You mean here, thank you. Yeah. And then it becomes 1. Okay, so let me write it in that way. So it becomes 1 over 1 plus c to the 4 to the 2. And then I have absolute value of 1 minus 3c to the 4. Okay. So what we can do, I want to show that definitely this number is less than 1 over 50. And what I know about C, I know that C lies somewhere between 1 and 1.1. Okay, so I hope that you agree with me. This one is smaller than 4. Do you agree? Because C is less than 1. Oh, sorry, C is greater than 1. It is between 1 and 1.1, so it is greater than 1. So 1 plus C to the power of 4 becomes greater than 2. If I square it, it becomes greater than 4. If I do the reciprocal, this means that 1 over 1 plus c to the 4 to the 2 is less than 1 over 4. So I hope that I could convince you that under this condition, this part at least is less than 1 over 4. So this means that this becomes definitely less than 1 over 400. And then I hope that you remember this inequality, triangle inequality for absolute values. If I have x plus or minus y absolute value, this is smaller than or equal to the absolute value of the first one plus absolute value of the second one. The reason that I more or less have to do this because I have a negative sign here. So this becomes absolute value of the first one, which is 1, plus the absolute value of the second one. But I don't need to put any absolute value here because 3 and c to the 4 are positive. So it becomes 3c to the 4. And then I also know that c is less than 1.1. So this is definitely smaller than 1 over 400. And 1 plus 3 times 1.1 to the power of 4. So I don't know, this we need to convince ourselves that this is smaller than 1 over 50. Okay, so how can I convince myself it is smaller than 1 over 50? So let me multiply by 400. This becomes 8. I move 8 to the right hand side, it becomes 7. Divide by 3. So I need to convince myself that this is smaller than 7 over 3. I don't know, do you agree that this is the case? Because this becomes 1.21. And 7 over 3 hopefully is bigger than this one, yes? Yes, definitely it is bigger than that one. Do you agree? Yes, so I don't think it is hard. So, by the way, let me calculate to make sure using the calculator. So 1.1 to power 4. So to power 4, and then multiply it by 3, and then add 1 to it. So the answer is, and then divide this by 400. So the answer that I get for this, if I calculate it, is 0.013, etc. Okay, and this is definitely smaller than 1 over 50, because 1 over 50 is 0.02, yes? Yes. Okay, it might be in the exam you can approximate them with, you can find another lower bound that these things are smaller. So for example, if I consider this 2, then I think that is also, if I write this as a smaller than, instead of this I replace it with 2, 16, and then it becomes 49 divided by 400, which is smaller than 50. No, this doesn't work. Okay, anyway, but this number is exactly this number, and everyone agrees that this number is definitely smaller than 1 over 50. So what we did is actually correct. Any questions? Okay, so yeah, let us stop here, have a break for 10 minutes, and then come back and solve the other parts of the problem. Thank you. Okay, so now let us go and solve the next question. So the ellipse E with half axes A and B both greater than 0 is given by this equation. Find the largest possible area of a rectangle with all corners on the ellipse E and where the sides of the rectangle are parallel to the principal axes. Okay, so this shouldn't be, of course they haven't mentioned A is greater than B or B is greater than A, but usually when we don't mention it, we consider A is greater than B, so it becomes an horizontal ellipse, yes? So it would be more extended on the X direction than a Y direction. So if I want to have an idea of the problem, so let me first draw the ellipse. So let us consider that this is our ellipse. Yeah, this is not, I want to keep it horizontal. Yeah, it's better now. So now that I have these axes, so let us consider this is the x-axis and this is the y-axis, yes. Okay, so if I understood the problem correctly, we want to find, because there are infinitely many rectangles that you can consider whose vertices are on the ellipse and the sides are parallel to these axes. Yes, for example, this is one of those rectangles. Or I don't know, this is the other one. For example, this is the other one. So all of these triangles, so you see that there are infinitely many triangles with that property. What we were supposed to do, we want to find the largest area among these rectangles. Okay, so what we can do, we can consider one of them. For example, let us consider this rectangle. Okay, something like this. If we want to find this area, I think this is also a very simple problem. Here, I want to find the maximum area. Yes, so for example, here, let me consider this length to be x and this length to be y. And if I ask you what would be the coordinates of this point, then it becomes clear that the x coordinate is just x, the y coordinate is y. But on the other hand, you see this point lies on the ellipse. So it means that the coordinates, so x and y, lies on the ellipse, on E, ellipse E. So this implies that its coordinates satisfies this equation, yes. Okay, now the area is equal to, if I multiply x by y, I will get the area of this part, but immediately it's clear by symmetry I need to multiply it by 4 to get the area of my rectangle. So the area of my rectangle is 4 times xy. This 4 is coming from this consideration, yes? And you see that this is a function of two variables, x and y. But if I want to use derivatives and things like that, I need to write it as a function of one single variable. Of course, the second one is a dependent variable. So I go back to this equation. I will try to find y squared. I want to eliminate y in favor of x, so it becomes 1 minus x squared over a squared. I multiply both sides by b squared. And then I take the square root. Because y is positive, you see I am considering this to be y. So it is in the first quadrant, so y is positive in my setup. So that it means that it becomes only positive. A square root of b squared minus b squared over a squared x squared. But I can simplify this a little bit. For example, under the square root sign, I can factor b squared a squared out. Then it becomes a squared minus x squared. To see why this is right, I multiply this back here. Then this a squared and this a squared are gone. I get b squared. And when I multiply this by that, I will get this one. So what I have done here is correct. Why this is useful? Because b squared over a squared can be written as b over a outside the square root. And it can take a simpler form. And then what I do, I will take this one and replace it here. Then the area becomes a function of only x, yes? So what I do, I simplify it. So it becomes 4b over a. These are just constants. And then x square root of a squared minus x squared. And by the way, I don't put absolute value here because in the problem it's mentioned that both of them are positive. Okay, now if I ask you, is there any limitation, is there any interval for x? In my setup, x starts from here and can at most go up to here, which is a here. Why this is a? Because if I put y equal to 0, this is the x-axis. So if I want to find the intersection point, I put y equal to 0. and then x squared becomes a, so it means that x is plus or minus a, but in my setup x is positive a. So the interval that I am looking for, I have for x, is somewhere between 0 and a, which is actually expected here. So then I use the notion of derivative. So I differentiate this. So this is a constant, but this is a product rule. So it becomes the derivative of the first one, which is 1 multiplied by the second one, plus x times the derivative of that square root. So in the numerator, the derivative of what is under the square root sign, and then divided by 2 square root of a squared minus x squared. So let me simplify this a little bit. So this becomes 4b over a, and then I have this. So here this 2 and that 2 are gone, and then minus x times x minus x squared. Okay, so this is my derivative. So you know that for finding maximum, you need to put the derivative equal to 0. So when I put the derivative equal to 0, this cannot be equal to 0, so this means this is equal to 0. When this is equal to 0, it means that these two expressions should be equal. So this implies that square root of a squared minus x is equal to x squared divided by this expression. And then I multiply both sides by this. So then it becomes a squared minus x squared is equal to x squared. So this means a squared is equal to 2x squared. And this means that x is plus or minus a over square root of 2. But I am working in this interval, so minus a does not lie in the interval. Okay, so the only acceptable answer is this one. Okay, so what we have to do, of course, you need to convince yourself this is the maximum, but you can do it two different ways. Probably you can convince yourself this is the maximum either using the first derivative test or second derivative test, but it is much easier. Do you remember we talked about that if a function is continuous on a closed interval, it is guaranteed that this function has a maximum, absolute maximum, and absolute minimum. To determine that absolute maximum and absolute minimum, we differentiate the function and calculate the numbers within the interval. I calculate this value, the value of the function at here and there and there. The highest value achieved is the maximum. But it is clear that if I calculate a of 0 or if I calculate a of a, both of them are equal to 0. Because if instead of x I put 0, everything vanishes. If instead of x I put a, again everything vanishes. So it is clear that I have to put this one here to find the maximum. So I calculate a at this number. So I have 4b over a. Instead of x, I put a over square root of 2. And then square root of a squared minus x squared, which becomes this. So here, if you see, this a and that a are gone. So it becomes 4b over square root of 2. And then this becomes a over square root of 2. Because this number is 1/2 a squared. Okay, and then what happens? So this becomes 4ab divided by 2, which is 2ab, area units. Yes, so the maximum value for the area of these rectangles is 2ab area units. Okay, any questions? Okay, so let us go to the next problem. Oh, I didn't expect this. This is a theorem. This is the first fundamental theorem of calculus. Yeah, so let f be a function defined on this interval. Assume that f is continuous, increasing and positive on I. Let a of x denote the area between the graph of f and above this for any given. So let me see what is going on. So you have, let me sketch something for ourselves to understand it better. But this is actually just by reading you can solve this problem. This is the first fundamental theorem of calculus. I don't know if I remember the proof, but let us go. F is a function defined on this interval from a to b. So this is interval from a to b. So because that is a closed interval, so these points are included. Assume that f is continuous, so it means the graph of the function doesn't have any discontinuity, increasing and positive on I. So it means that if I restrict myself on this interval, so let me draw a solid line because this is included. So what is happening here, the function that I have is increasing and positive on y. So it doesn't go below the x-axis because it is positive, and it is increasing. So the function starts from somewhere, goes up and up. So it will not come back. It's something like that. Okay, so for example, let me just draw, I don't know, some graph. It's increasing all the time. Something like this. And then let a of x denote the area between the graph of f and above this. So it means that x is somewhere here in this interval, and then this area that you see, is called a of x. And of course it becomes clear that this area depends on x. If I move x here or there, I will change this area. Show the fundamental theorem of calculus saying that a is differentiable and that a prime of x is this one. So if I ask you what you can write for a of x, you would say that this a of x is the integral from a up to x of my function f t dt. My goal, do you remember I talked about this, but I didn't prove it. I just gave you the result and used the theorem. But here we are supposed to show that this is equal to f of x. Okay, so if I want to calculate the derivative of a function, there is only one way to do that, and that is the definition of the derivative. So it becomes a calculated at x plus h minus a of x, and then divided by h when h goes to 0. So this is the definition of the limit. Now if I ask you what is a of x, is definitely this one, so no problems. But a of x plus h means that you replace x with x plus h. So this becomes integral from 0 to x plus h, and then you have f of t dt minus integral from 0 to x, and then you have f of t dt, and divide everything by h, and h goes to 0. Okay. So what we can do, so here I will change the limit between these two. So I will swap them. I will take 0 up and x below. Oh, by the way, this is not 0. Why I am writing 0? Sorry. This is my bad handwriting here. So this is a. This is not 0. Okay. Okay, so let me do it in this way. So this becomes the limit. Instead of going, so where is x plus h? Of course, it is not clear. Might be h is positive or negative. So, but let us assume that x plus h is here. So instead of going from a up to here, I go from a to x and then from x to x plus h. So this integral can be decomposed as a sum. Instead of going directly from a up to x plus h, I go from a to x. This is the property of the definite integrals. Then I go from x to x plus h. Okay, so what I have written for these two is just instead of this, and then you see I have minus this expression at the end. Okay, and then divide everything by h. H goes to 0. So this is exactly the beginning, the one that you see here. So they are cancelled, and then I will get the limit of integral from x to x plus h f of t dt divided by h when h goes to 0. Okay, now it is mentioned that this function is continuous. So there is something I didn't talk in my lectures because I didn't think that they will give you any questions related to proving theorems. But anyway, let us just do it here. So if this is called I don't remember the name, the mean value theorem for integrals, I think. So mean value theorem for integrals. Okay, so what does this tells you? This tells you that if you have a function continuous on the interval from a to b, then there exists a c in this interval such that the integral from a to b f of x dx is f of that c multiplied by b minus a. So this is a simple theorem. It's only useful for proving theorems, okay? So let me just write this here. Okay, so now I can use this mean value theorem because here it is guaranteed that this function f is continuous on that interval. So what I can write, I can say that mean value theorem for integrals implies that there exists a c in the interval, so there exists a c between x and x plus h. But because this c depends on x, so I would write it as cx. This c depends on x here because x is a variable here, and then c should be a number between these two. When x is changing, this value should also change. So that itself is a function of x. So there exists a c of x between x and x plus h such that integral from x to x plus h f of t dt, it becomes f of that c of x multiplied by, you see, the final limit minus the lower limit. So it becomes the final limit here is x plus h minus x. But then this becomes f of c of x times h. And then I will put this back in this equation. So a prime of x is equal to the limit. In the numerator I write f of c of x times h divided by h goes to 0. So this becomes the limit of f of c of x. H goes to 0. Okay. But if I ask you where c is, you would say that c of x so c of x is between, for example, x plus h and x. But if I calculate the limit of this one, when the limit of x when h goes to 0 is just x, it's a constant. The limit of x plus h when h goes to 0, it becomes x. So by a squeezing theorem, this gives me that the limit of c of x when h goes to 0, it becomes x. Yes? And then because f is continuous, I can write it as f, and then I can slip the limit inside. Yes? H goes to 0. So f is continuous. And then this limit, let me explain it again. So this becomes f of x, and then we are done. So it was actually very technical. So here, what I wrote for you is that according to this mean value theorem for integrals, this integral can be written as f calculated at a number, but this number, even though it is fixed, but it depends the value of x that you have chosen from the beginning. To show that dependence, I put x in pair of brackets. This c of x is between x and x plus h. And what I have written here is not 100% correct, because the way that I have written here, I'm assuming h is positive. If h is negative, h plus h should be on the left hand side and x should be on the right hand side. But it doesn't matter, because the limit of the right hand side is x when h goes to 0. The limit of the other side is also x. By the squeezing theorem, the limit of the middle one is also x. And then we have a rule. If I have a limit of composition of two functions and this function is continuous, you can slip the value, you can slip this limit into the first function and then calculate this limit. So the limit of c of x when h goes to 0 is x, and then I have f, so it becomes f of x. And then if you see this one with the last one, so we were able to show that the derivative of a is equal to f. I don't know, so this is actually a fundamental theorem of calculus, so that you should expect that this is a little bit technical because it carries the name fundamental theorem. Yes? Any questions? But it is extremely important to most of the time. This is the first time that I see that they have asked you to prove, but most of the time you need to know the theorem and use it. I think you have solved some home assignments based on the derivative of integrals before. Okay, so now let us go to the next problem. Number 8. The function f is given by this. Determine the biggest open interval containing 1 where f is invertible. I just thumb through the solution. I think the person who wrote the solution made a calculational mistake. So let me do my calculations again to see how it works. But the function f is given by this rule. Determine the biggest open interval that contains x equals to 1 where f is invertible. Okay, do you remember f is invertible if and only if f is 1 to 1. And it is 1 to 1 if and only if it is either always increasing on that interval or it is always decreasing. It should be monotone function. So if they actually asking you this to see if you know about these theorems. So if this function is supposed to be invertible, it should be either increasing or it should be decreasing on that interval. Okay, so here this means that I need to take the derivative of this function. So I take the derivative of f. For the first part, I use the quotient rule. The derivative of the numerator 1 multiplied by the denominator minus the derivative of the denominator multiplied by the numerator and then divided by denominator squared. And then I have 4 over 5, and that one function is famous. The derivative of arctangent is 1 over 1 plus x squared. So let us simplify this derivative. In the numerator it becomes 1 minus x squared, yes, because this becomes positive x squared minus 2x squared, and then divided by, oh no, I think I've made a mistake in my first calculation. Okay, let us just do it patiently. So then it becomes 5 1 plus x squared. Yeah, please check my calculations. Yes, everything seems right now. Now I take the common denominator. So the common denominator between them is 5 1 plus x squared to power 2. So it means that I have to multiply the first one by 5 and the second one by 1 plus x squared, yes? So I divide this by that, it becomes 5 times. I multiply 5 here, it becomes this. I divide this in my head by this one, so it becomes 1 plus x squared times, and I multiply it here. So let me now simplify that. So it becomes 5 minus 5x squared plus 4 plus 4x squared, and then divided by this expression. And if I simplify it finally, so it becomes 9, no, so the person who actually solved the problem was right. So here 5 1 plus x squared to the power of 2. Okay, but now I want to make the function invertible. Okay, so it doesn't matter, you can make it invertible by making it decreasing function, or you can make it invertible by making it increasing function. But here you are supposed to find the biggest open interval containing x equals to 1. So let us see what we can do here. So the denominator is positive always. So positiveness and negativeness of f prime only depends to the numerator. Okay, so I would say that f prime x is greater than or equal to 0 if and only if the numerator is greater than or equal to 0. This means if and only if x is between minus 3 and 3. And f prime of x is less than or equal to 0 if and only if 9 minus x squared is less than or equal to 0. This means that either x should be less than minus 3 or x should be greater than or equal to positive 3. Actually, both of them are correct for making it invertible. If I choose this, the function is always increasing and it is invertible. If I choose this, then the function is always decreasing and again invertible. But let us look at the question. First of all, we need an open interval, the biggest open interval, but it should contain 1. It's clear that this does not contain 1, but this contains 1, and I want to have it an open interval. So the answer would be minus 3 less than x less than 3. So this is an open interval. It's the biggest open interval, because if I go beyond this, I will fall into this part. In this part, the function decreasing, so is decreasing. So it means that the function goes up, but if I go to the other side, then the function goes back. When this happens, the function is not one-to-one and it is not invertible. So I need to avoid that. Either I should stay here or there, But because I want to have an open interval containing 1, I choose this interval from -3 to 3. Yes, is that understandable? Okay. Let us now go to the... Is there any other? No, this is the last problem actually for this exam. Actually, this was a quite simple example. I don't know what you think. Let us see what is the last problem. So number 9, determine whether there exists a number r greater than 0 such that this happens. Okay, so this is not exactly clear what we have to do. Hopefully okay, so I hope that you agree with me that sine squared x over x squared is less than or equal to 1 over x squared. Yes, do you agree? Because we know that sine squared is always greater than or equal to 0, but it cannot be bigger than 1. So maximum value of sine squared is this. Okay, and then so I would say let r greater than 0 be a real number. Okay, because this is smaller than this one, it's integral. Let me write, this is smaller than this one for all x. Yes, of course, except 0. And then I would say that integral from 1 to r of sine squared x over x squared dx is definitely less than or equal to 1 to r 1 over x squared dx. Okay, and I hope that you agree that this integral is definitely smaller than from 1 to infinity, 1 over x squared dx. By the way, if you want to write such a thing, you need to be careful that this should be convergent, but this is convergent. Why? Because if you remember, this is a p integral with p equals to 2. So if you go back to see my lectures, I talked about p integrals. When p is greater than 1, then this integral converges. So why this is the case? Because here 1 over x squared, for example, assume that this branches this one, you will start from 1 up to r. But here you start from 1 and then you go up to infinity. It is clear that you can cover more areas when you go up to infinity. So definitely this integral is less than or equal that integral. Not because the integrand is smaller, because the function is positive and then the interval here is greater than this interval, is bigger, is more expanded. Okay, but this integral we can simply calculate. So this becomes minus 1 over x from 1 to infinity. If I calculate this, it becomes how much? It becomes, by the way, let me solve this in this way. It becomes 1. And then, so this means that the answer to the first part is negative, because we were able to show that this integral for any number that you like is smaller than 1. So it is not possible that you can choose a number so that the value of this becomes bigger than 100. And might be you even don't need to do that. Let us, for example, let me change my color and see that what happens if I go in this direction. So let me calculate this. The integral becomes minus 1 over x, and I go from 1 to r. And then what happens, it becomes minus 1 over r plus 1. So this is 1 minus 1 over r. Yes? Okay, I think this is easier. We don't need to bring infinite integrals here. So we guaranteed that this integral is smaller than this integral, and then we calculate this integral, it becomes this number. Is it possible to make this one bigger than 100? The answer is no. Yes? Because when r is positive, 1 over r is also positive, and then you are subtracting a positive number from 1, so definitely it is smaller than 1. Yes? When the bigger one is smaller than 1, so let alone that for the smaller one, a smaller one cannot be bigger than 100. So the answer to this is negative, so we would say no. Okay. And then let us do the other one. So the other one seems to be yes. Why is that? Determine whether there exists a number r such that this happens. Because if you remember, I told you that in large values of r, n squared will dominate. So you can, for example, ignore that, and then it becomes square root of n squared, and this becomes 1 over n. But I told you this is a famous series. It's harmonic series. If of course if it goes from 1 to infinity, harmonic series tends to infinity. Okay. So, but if we want to make it precise, we have to write it in proper form. So we say that, okay, so 1 over square root of n squared plus 1/2 is definitely smaller, no, definitely bigger than 1 over square root of n squared plus n squared. Yes, do you agree? Because I want to get rid of this. Unfortunately, if I just eliminate this, I don't reach to what I want, because if I just eliminate this, I cannot say this is bigger. This should be smaller than this. Yes? And then this becomes 1 over n. This diverges. If the bigger one diverges, I cannot conclude anything about the smaller one. So this is why I cannot simply get rid of this 1 over 2. Because I want to have this direction, so I have to make this denominator bigger. So I chose to write n squared, and that's definitely the case because the lower value of n is 1. So when I raise it to power 2, n squared is a number greater than 1, and of course 1 is also greater than 1/2. So what I have written here is completely okay. But what is the benefit of that? The benefit is that you can write it as square root of 2n squared, and then it becomes 1 over square root of 2 times 1 over n. Okay, so then what does it mean? It means that sigma one over n squared plus 1 over 2, n goes from 1 to infinity, diverges to infinity, since the series sigma 1 over square root of 2 1 over n, n goes from 1 to infinity, diverges. It's a multiple of It's a multiple of harmonic series. So sorry, I have to write diverges to infinity. Okay, so let me explain again. So first of all, I hope that you agree with me this is greater than this one, and I did some simple algebra, I got this one. Now let us talk about infinite series, up to infinity, not R. This diverges to infinity. If someone asks you why, we have a comparison test. We say that this series is a multiple of harmonic series, and harmonic series we showed that it diverges to infinity. The terms of these series is greater than the terms of the harmonic series. So if the harmonic series diverges to infinity, the bigger one also diverges to infinity. So what is the meaning of this? When this series diverges to infinity, it means that if you are patient and increase the value of n, you definitely will be able to be greater than any number that you like. So 100 is not a big number. This diverges to infinity. It means that there is a number that you can choose, so that when you go up to that number, it becomes greater than any number that you like. So the question is that, can you determine a number r so that this happens? The answer is yes. Can you find a number that it is bigger than 1 million, for example? The answer is again yes. Because this series diverges to infinity, so it becomes bigger than any pre-assigned number that you can imagine. So the answer to the second part is yes. The answer to the first part is no, and that was the reason. Okay. So that is the end actually of this exam. I don't know, this exam was not a hard exam, and I actually try to check the hard questions, so I try to cover more or less the hardest questions in the exam during my lectures. So I don't think that you will face a very big problem if you have